All right, ladies and gentlemen, here we are with the PEMDAS Order of Operations worksheet. This is really a review for some, and for others it's a gentle introduction to order of operations. PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. And it's often best remembered by the mnemonic. Please forgive the spelling there. Please excuse my dear Aunt Sally. So please stands for parentheses, excuse for exponents, my for multiplication, dear for division, aunt for addition, and Sally for subtraction. One common flaw with PEMDAS is that it's not always right. The best way to think about PEMDAS is you always want to work your grouped terms first. So look for grouping symbols, and sometimes they're really obvious. For example, down here, these parentheses, that's a grouping symbol. So you want to work the internal part of the parentheses before proceeding. And then at other times it's not so obvious, like here in number 2, there's no parentheses, but we want to work the numerator first and then see what we've got in terms of a fraction. One final thing to remember is the fraction bar really means division, okay? In this case, we're simply going to reduce the fraction. We're not necessarily going to divide, but just remember that division comes in many forms, and so does multiplication. These two numbers here that are wrapped in parentheses, when you see two parenthetical expressions, in this case they're just numbers wrapped in parentheses, in between the two parentheses there's an invisible multiplication symbol. So 5 and 6 are being multiplied. So we would do that first. In fact, on number 3, it might be helpful to put and you're allowed to do this, a grouping symbol there. So you know to do 5 times 6 and then add 4. But PEMDAS is one of those things that it frustrates even experienced mathematicians. They argue about it because it's not always right, but in 99% of cases, PEMDAS is going to save you. Now, one thing to remember is that when you're dealing with one type of operation here, like multiplication, we just multiply left to right. We would do the same thing if we had multiplication and division. Those kind of go together. We would just move from left to right. Same thing with addition and subtraction. If those are mixed up, you would just move from left to right. Okay? The best thing to do as we leave this introduction is just to remember common sense. And that common number sense will only come to you with time and practice and many, many mistakes. That's why one of your gifts was the eraser. Okay, and that's why I ask not to use pen, because if you're not erasing in mathematics, then you're not learning. All right, let's begin with number 1. 2 times 6 times 5. Well, we only perform one step at a time, so what I'm going to do is say 2 times 6 times 5, and this symbol here, this dot, that is another way of writing the multiplication symbol. As we move up from basic mathematics to algebra, this X disappears completely because it gets confused with the variable x. It's too similar. You see, it's too similar. So we find other ways of expressing multiplication. Anyway, all right, 2 times 6 times 5. So first I'm going to do 2 times 6, which is 12. So this equals 12 times 5. And notice how I'm showing this intermediate step. Okay? We never do anything in our heads. We write it down. And 12 times 5 is 60. Okay? So there's the work for number 1. I'm still having a number of students not quite sure how to show work. And so my best advice is to watch these videos because you're learning how to show work. And moving on to number 2. So we have 7 minus 2 over 5. Okay, the implicit grouping symbol is here in the numerator. We're going to perform that first. And so let's see what that equals. Well, 7 minus 2 is 5. So my numerator is 5 over 5. Now, I might know the math fact that anything divided by itself is 1, but it's helpful to show the fraction reduction. We're going to divide 5 and 5 by the greatest common factor of 5 and 5, which is 5. And that leaves behind 1 over 1. And so, again, we can show an intermediate step, 1 over 1. So 1 over 1 equals 1. So again, that's the work that I want to see for that problem. And don't get me wrong, I understand that these simple and very trivial problems, it's kind of like, are you serious? You want me to show work for something that easy? Trust me when I say this stuff is going to get so complicated that you will absolutely have to take it one incremental step at a time. Moving on to number 3. We discussed before that we were going to group the 5 and 6, which are multiplied. And we're going to go ahead and write this out a little bit of a different way. So, and you can do this. You're allowed to reinterpret the problem. I think this is a little bit more clear. Now it's really clear that we're going to multiply 5 times 6 and then add 4. Well, 5 times 6 is 30. So I write down 30 and then bring down this plus 4. Okay, notice I didn't just mentally add, right? So now we do 30 plus 4, which is 34. Put that in the red box. And move right along. Okay, here we have 12 divided by 4 plus 6. Okay, so we're just going to note that we perform the division first. And so I'm going to say 12 divided by 4. And I'm adding the grouping symbol. So there's no question about what to do. Plus 6. Let's zoom in a little bit. There we go. Okay, so now this equal sign is important. So don't forget to draw this, because what you're saying is you're saying what's written above is equal to what's written below. We're just simplifying. So every step of this is equivalent. This is equivalent to this, and what I'm going to write is also equivalent. So 12 divided by 4 is 3, and I can lose the parentheses now. 3 plus 6. Okay, well, 3 plus 6 is 9. Another equal sign, 9. Okay, so everything is equal. And that's number 4. Moving on to number 5. So we have some left to right subtraction going on. And the thing to recognize here is that we have this 3 in the denominator here. We have a 2/3. So before we even begin, we need to convert 6 and -1 into fractions with 3 in the denominator. So it may be useful, in fact, it's crucial to remember that 6 equals 6 over 1. Hang on a second. Get some better light on this. 6 equals 6 over 1, and -1 equals -1 over 1. All right, that's crucial, okay? So we need to know that. I'm going to put this in some braces here so you can just remember that. That's kind of like a little note. Okay, now let's go back to the problem. So we're going to rewrite this problem as 6 over 1, and then I'm going to leave some blank space right here on purpose. I'm going to put the minus sign there. You'll see why in a second. 2 over 3. And then, again, some blank space on purpose. And then minus 1 over 1. All right, now why did I leave the blank space? Well, I need the 1 here and here to become 3. So for the 6 over 1, I'm going to multiply by 3/3. And the -1 over 1, I'm going to also multiply by 3/3. Now this looks a little weird. It looks like I'm messing the problem up. But this is a very rudimentary skill. So we just kind of group those and we'll see what we get. Now I'm going to multiply across the top and across the bottom for both of these. And just keep in mind that that symbol right there that looks like a fraction bar is a minus sign. It's a negative symbol. Anyway, 6 times 3 is 18. Over 1 times 3, which is 3. Minus 2/3. See, I needed that common denominator. And then we know this is going to be negative, minus, and then 3 times 1 over 3 times 1, right? So 3/3. Okay, so notice that I have all 3's. And so I can actually rewrite this as 18 minus 2 minus 3 all over 3. Okay, so now we work from left to right on the top. 18 minus 2 is 16. Okay, so my next step would be to say 16 minus 3 over 3. Well, 16 minus 3 is 13. So I can say 13 over 3. And I can leave it as an improper fraction because there weren't any instructions. Or since I'm not sure how CUDA will ask for it, we could go ahead and say 3 goes into 13 4 times with 1 as a remainder. So that would be 4 and 1/3. Okay, so those are the two possible answers. Excellent. Moving on to number 6. And we talked about this. We're going to leave the 3/5 alone for a minute and work on this guy in here. Now, the very first thing to note is that 2 can be rewritten as a fraction as 2 over 1. That's very important. Okay, so we're going to rewrite this expression as 3/5. And I'm just going to put a times symbol here. And then in parentheses, notice how I'm adding a little space. Just give yourself some space. I'll put 2 over 1. And then we're dividing by 7/4. 7 over 4. Okay, so I'm dividing a fraction by a fraction, and that means we need to employ keep, flip, change. Remember, I would say multiply by the reciprocal. The reciprocal is 4/7, so multiply 2 over 1 by 4 over 7. To me, we multiply by the reciprocal. In my mom's generation, she would say invert and multiply. Inverting 7/4 would make it 4/7. So it's identical to multiply by the reciprocal. And then KFC is what the kids say today. And what that means is keep the first fraction, flip the second fraction. Notice that flipping is just another way of saying invert or take the reciprocal. And then change the symbol from division to multiplication. Invert and multiply, multiply by the reciprocal, keep, flip, change. They're all identical, okay, ways of saying the same thing. We're going to flip the 7/4 over upside down and make it 4/7 and then change the division to a multiplication symbol. So we're going to go ahead and put an equal sign here. Notice we haven't touched the 3/5 yet, so we're just going to rewrite it. There's a lot of rewriting in math. Okay, I'm still going to put this multiplication dot out here in space. And I'm still going to use my grouping symbol because we're not done yet. And I have 2 over 1 times 4 over 7. All right. And now my eyeballs start looking diagonally. Can I reduce 4 and 1? How about 2 and 7? No, I can't. Okay. Sometimes you can. So I look at those diagonals to see if I can reduce, but I can't. So instead, I'll just go ahead and multiply across the top, multiply across the bottom. And we're going to be able to get rid of those parentheses right now. So now I've got 3 over 5 still coming down, unchanged, times, well, 2 times 4 is 8. That's my numerator. Over 1 times 7, big brain time, is 7. Okay, now, once again, start looking at your diagonals. 8 and 5 are prime, so there's no reduction there. 3 and 7 are also prime. Nothing can be reduced, folks. It just didn't work out for us. So we're just going to multiply across the top, and we're going to multiply across the bottom. Now let's see what that gives us. By the way, I already know that because everything here is co-prime, when we get done multiplying across the top and the bottom, there won't be any way to reduce the fractions. But that's just a side point. 3 times 8 is 24. And 5 times 7 is 35. And that's irreducible, and I'll show you why. If I were to prime factor 24, think about what multiplies to be 24. People say 2 times 12. And what's 12? 2 times 6. What's 6? 2 times 3. So I've got 2 times 2 times 2 times 3. Okay, that's the prime factorization of 24 over the prime factorization of 35, which is just 5 times 7. They're all primes. Everything there is prime. Notice how there are no duplicates in the numerator and the denominator. Yeah, there are three 2's up here, but there's no 2's down here. And there's no 5's or 7's up here, and there's no 3's down here. You see, there's nothing that I can cancel out, which means that 24/35 is a fully reduced fraction. Okay. Now, I have no idea if CUDA wants you to put that in decimal form or something, and quite frankly, I don't care. I would just leave it like that. It's a proper fraction. Good enough for me. And we are moving on to the second and last page. These are only 10 question assignments. It's hard to see, but that is number 7. All right. So first things first, I've got this 5 hanging out there. And I'm just going to remember that 5 is equivalent to 5 over 1. All right? So when I rewrite this, One of the reasons I'm rewriting is to get away from that staple right there, which is kind of messing up my pencil. I'm going to write 8 over 5 okay, and then there's a division symbol, and then instead of 5 by itself, I'm going to put 5 over 1. And then it wants me to say plus 5 over 2. Minus 2 over 3. Okay, fair enough. All right, so first, because of please excuse my dear, so dear for division, we're gonna deal with this division first, and we are gonna use KFC to do this. Keep, flip, change. That's what the kids say these days. Back in the day, what they would say is, it is not for us to reason why, just invert and multiply. I don't know. I miss old school. So we got 8/5. So keep the first fraction, flip the second fraction, change the sign. Change the sign from division to multiplication, and flip that second fraction to 1/5, aka multiply by the reciprocal. All right, remember we're still grouping here. We're going to group these. And we are going to bring down the rest of this problem. So I got plus 5 over 2 minus 2 over 3. Okay, so there's my whole problem. And now I'm going to take a look. Remember, diagonal, 8 and 5, no common factors. 1 and 5, nothing I can do there. So we're just going to multiply across the top, and we're going to multiply across the bottom. And we can drop the parentheses now. Well, 8 times 1 is 8. And 5 times 5 is 25. Okay, so I have 8/25. This fraction cannot be reduced. 8 equals 2 times 2 times 2. 25 is 5 times 5, so you can't reduce the fraction. We are now going to add to this number 5 over 2. And then we're going to subtract 2 over 3. Okay, now the thing is, we can't do anything until we have a common denominator. So I'm looking for the least common multiple of 25, 2, and 3. And because of this 2 right here, think about 25 for a second. Think how it works, the multiples. 25, 50, 75, 100, 125, 150, 175, 200. Well, 2 multiplied by anything will never end in a 5. Never, never, never. All right? 3 can end in a 5. Just think about 3 times 5. That's 15. Okay? But 2 will never end in a 5. So I know already that the multiple I'm looking for is going to be one of the multiples of 25 that ends in a 0, like 50, 100, 150. Okay? Like that. So let's try 50. Well, 3 won't go into 50. Okay, try 100. 3 won't go into 100. Try 150. Ooh, remember before when we said 3 times 5 is 15? Well, 3 times 50 is 150. So that'll work. And 150 is an even number, so that'll work for 2. 2 times 75, 3 times 50, and then 25 times 6. All right, so what I'm going to do is I'm going to multiply 8 25ths by 6 over 6. I'm going to multiply 5 over 2 by, what am I trying to find here? 75 75ths. So let's see, how am I going to fit that in here? 75 over 75. And then I'm going to multiply 2 over 3 by 50 50ths. Okay. Now these have all suddenly become little math problems that we got to do. All right. And you're just multiplying across the top and across the bottom. Okay. Remember, the goal is to get 150 in the denominator. All right, starting here, we got 6 times 8 is 48. Over 150. Oops. Okay, now you got plus 75 times 5. Little side work here. What is 75 times 5? $375. Okay, so I got 375 up here. Over 150. Minus, and then 2 times 50 is 100. Over 3 times 50 is 150. Okay, so I feel like we should, since now we have a common denominator, we're going to rewrite this as 48 plus 375 minus 100 all over 150. Okay, and so what you want to do is work left to right in the numerator. So first thing, we'll add 375 and 48 over here in side work. Okay, 5 plus 8 is 13. Carry the 1. 7 plus 4 is 11, plus 1 is 12. Carry the 1. 3 plus 1 is 4. So I got 423. That was 48 plus 375. Now I'm just going to subtract 100. that's easy enough to do. It's just going to be 323. Okay, so this is going to equal 323 over 150. Or, if they want you to make it a proper fraction, 150 will go into 323 two times, leaving behind 23. So 2 and 23, 150ths, if they make you do that. Okay, so those are your, to me, I don't care either way. But who knows what the software wants. All right, that was number 7. We are now moving on to number 8. Okay, so in number 8, we have a whole bunch of addition and subtraction, and it's grouped. So we're going to do that first. So we're just rewrite 4/3 minus, and then in the parentheses, we have 3 plus 2 plus 2 minus 6. Okay. Now I'll continue and start to whittle down. So I've got 4/3 minus 3 plus 2 is 5. So I've got 5 plus 2 minus 6. And that equals 4/3 minus 7 minus 6. 5 plus 2 is 7, which leaves me 4/3 minus 1. And I remember that 1 equals 1/1. So I can say 4/3 minus 1/1. And in order to make that common denominator with 3, I'll just multiply 1/1 by 3/3. And so I'll get 4/3 minus 3/3. And that's equivalent to 4 minus 3/3. 4 minus 3 is 1. So my final answer is 1/3. Again, the problem I see isn't so much that students can't get these answers. It's that, and believe me, I remember, you're in a rush and you don't want to write all that down. Okay, you want to do it all in your head and just write down 1/3 and circle it. And again, when the problems are trivial like this, I get it. But when we start throwing a bunch of letters in there and squares and cubes and square root symbols. This habit of doing every tiny little step in its own row is going to save your life, okay? And your sanity. Okay, moving on. Well, first I'd like to point out that we should probably group the multiplication, because please excuse my for multiplication. So we're going to perform these two multiplications, 6 times 5, and then we'll do 5 times 5, and then we'll add those two products together. It's basically the goal. So I've got here 6 times 5 plus 5 times 5. Fair enough. Well, 6 times 5 is 30. And normally I'd write out plus 5 times 5, but we could just write plus, and then 5 times 5 is 25. So we can put 25 here. And then we need to add 30 and 25. If you can't do it in your head, I don't recommend doing anything in your head. If you aren't totally sure, you can just add, and you get 55. Okay, now you don't have to worry about getting it wrong. Equals 55. Go back, put it in a box. Good to go. And now on to the final problem, number 10. We have a mixture here of addition and subtraction. And even though PEMDAS says Aunt Sally, meaning addition then subtraction, that's one of the reasons why people argue about that. We're just going to do the operations from left to right. So addition and subtraction, they're kind of on the same level. One doesn't supersede the other. We work from left to right. If there's no grouping symbols, we just work from left to right. So we're going to go 5 minus 4, take that difference, add 1, take that sum, and add 1. So, of course, I probably infuriating everybody because I like to rewrite the problem. I just like to write it again because it's mine. And I can say I'm going to do this first. Okay. Well, 5 minus 4 is 1. Plus 1. Plus 1. And I think the answer is obvious, but we'll say here, now I'm going to group these. 1 plus 1 is 2. Plus 1. And 2 plus 1 is 3. And we're going to put a red box around that. And that will conclude this tutorial video for PEMDAS. Thank you very much for watching.